Hi teacher and classmates. In this occasion I talk about Newton's second law. The Newton's second law, also known as the fundamental or law of dynamics, is the one that determines a proportional relationship between force and vibration of the amount of motion or linear momentum of a body. In other words, the force is directly proportional to the mass and acceleration of a body. Newton's second law is responsible for qualifying the concept of force. It tells us that the net force applied on a body is proportional to the acceleration that the body acquires. A constant of proportionality is the mass of the body, so that we can express the relationship as follows: F equals m for A. This law explains what happens if a moving body, whose mass does not have to be constant, acts a net force. That force will modify the state of movement, changing the speed in module or direction, especially. The changes experienced in the amount of movement of a body are proportional to the motive force and development in the direction of it. That is, force are causes that produce acceleration in a body. In this picture, I see the phenomenon of a law. If a moving train, a car with a low steady line stops on the rails because it tripped over an obstacle, its slow train to keep moving with the same speed and direction it had at the time of the crash. The expressions of Newton's second law that we have gives is valid for bodies whose mass is constant. If the mass varies, such a rocket burning full deuterium F equals m for A is not valid. Let's generalize Newton's second law to include the case system which a current vary. To do this, we will first define a new physical magnitude. This physical magnitude is the amount motion. It is represented by the letter P, and that is defined as the product of the mass of a body by its velocity, that is, P equals m for V. The amount of motion is also known as linear momentum. It's a vector magnitude, and in the international system it's measured in kg for ms. In the terms of the new physical magnitude, Newton's second law is expressed as follows: the force action in a body is equal to the temperature variation of the amount of the motion body, that is, F equals dp divided dt. In this way, we also include cases of the body whose mass is not constant. For the case that the mass is constant, remembering the definition of quality of movement and the product is derivative, we have F equal d mv dt equal m dv dt plus dm dt for v, as the mass is constant. Dm of dt equals 0. That is, the derivative of the amount of motion with respect to time is 0. This means that the amount of motion must be constant over time. The derivative of a constant is 0. This is the principle of conservation of amount of movement. If the total force action on a body is 0, the amount of movement of the body remains constant over time.